about to do problem number 2, and problem number 2 is sort of like one we've already done, or 2 we've done. It's sort of like 6 and 7 here, okay? So 6 and 7, you just look at the triangle and get the sine and cosine. Problem number 2, let me get some blank paper. I'll read it. Can y'all see that? Is it big enough or too small? It says, given that, this one's different. And the other one you were given cosine 2 theta, told find sine and cosine theta. Here you're given just cosine theta and told to find the double angles. Cosine 2 theta and sine 2 theta. Well, believe it or not, this is very similar to stuff we've already done. In fact, I'm going to start it sort of the way we did stuff on the first test. We're given cosine theta, oops, not cosine 2 theta, just cosine theta is negative 20 over 29. And then we're told something, sine theta is negative. Sine theta is negative. We need to find sine 2 theta and cosine 2 theta. So here's my thought process. I think, okay, what's the identity for sine 2 theta? There's only one of them. It's 2 sine theta cosine theta. It's that first double angle identity for sine that we derived. We'll state them nice and neatly for y'all. Well, here it is. Sine 2 theta. Well, we wrote it with an A. 2 sine A cosine A. So we already know cosine theta. That's negative 20 over 29. So if we just could figure out sine theta, then we'd have it done. Replace the sine theta with whatever it equals. So if I write this, x equals y equals r equals, can that sort of give you a hint on what I'm about to do? Let's see, I'm thinking cosine in terms of x, y, and r. That was our first definition of the trig functions. Cosine is x over r. R is always positive, so that negative does not go on r. R is always positive. That negative has to go on x. A lot of times we're told the quadrant we're in, but not this time. This time we're told sine theta is less than 0. So what's y going to have to be, positive or negative, in order for sine to be negative? Sine must be negative. So that green sine theta less than 0, the only time I'm using that is right here when I'm deciding y has to be negative. Ooh, y'all can't tell the green, can you? But it shows well on the computer, so. Now let's do x squared plus y squared equals r squared. And this is not nice, small, pretty number day, is it? Negative 20 all squared plus y squared is 29 squared. That negative 20 squared is 400. Let's see, what's 29 squared? 841. So we have y squared is 841 minus negative 20 times negative 20. That's a positive 400. So y squared is 441. So y is going to be, okay, the square root, but which square root? Positive or negative? Negative. Okay. Now, square root of 441, that 441 is divisible by 3, isn't it? Trying to figure out if I can reduce it at all. Hey, 441 is a perfect square. Don't I sound like an idiot, don't I? Square root of 441, negative 21. So it might be ugly number day, but it's all working out really nice. So y is negative 21 over 29. Excuse me. Y is negative 21. Sine theta. Remember what we're trying to find. 2 times sine theta cosine theta. So I'm going to come here. 2 sine theta y over r. So negative 21 over 29. Cosine theta, we were told, it's negative 20 over 29. And that 2 you might think of as 2 over 1. So just multiplying straight across. 2 times 21 times 20. That's 840 on top. And 29 squared, 841. So 840 over 841. And you think, oh no, we're only halfway finished. Actually, we're more than halfway finished. To find cosine 2 theta, there are 3 identities you could use for cosine, double angle identities for cosine. And since we already know sine theta and cosine theta, I'm going to use for cosine 2 theta, I'm going to write it as cosine squared theta minus sine squared theta. So I'm using the first double angle identity for cosine. And then, oh, here they are. See, for cosine 2a or 2 theta, I'm using cosine squared theta minus sine squared theta. Because we just found sine theta and cosine theta. With those squares, it's going to work out really nice. We have negative 21 over 29. Oops, I messed up. That's not cosine, is it? Cosine theta was the negative 20 over 29. Negative 20 over 29 squared. This minus is that one there. Sine squared theta. Oh, what did y'all tell me? Move it up. What's sine squared theta? That's y over r. Negative 21 over 29 squared. So the 29 times 29, that's 841. Negative 20 times negative 20, that would be 400. Minus, what's negative 21 times negative 21? Is that 441? Let's see what I did. Replace the negative 21 times negative 21 with a 441. So are we getting a negative 41 over 841? 1 and 2 are the messy, lengthy ones on this. Okay.